a different method to solve. Sometimes substitution involves solving for a variable and you get all these ugly fractions and stuff like that. So this is another method, and I hope you practiced your substitution lots, because once you see this method, you'll like this over all of them. However, if it's on a quiz or a test and I say you have to use substitution to solve, then you have to use that method. If I just say solve the system, you can pick whatever method that you like the best. So the way elimination works is you line up your x's and your y's and the constants, and then essentially you try to add them together and see if you can eliminate one of the variables when you do that addition. And that's why it's called the elimination method. So if I add this, I get 2x. Do you see if I add this, the y's cancel, and then I get equals 12. So then x equals 6, and I'm almost done, right? Once I solve for one of the variables, it's essentially just like substitution after that. You just sub it into another one. So I can say solve it into the first one. I get 6 plus y equals 5. So do you see what I did? I put 6 in for x plus y equals 5. So then I get y equals -1. So my solution is 6, -1. Okay, so you might say, holy, that's really easy, right? Well, I had a nice question to start with. So the next example, hold on. Okay, so I didn't verify my answer here, so let's verify. Remember, when you verify, you have to plug it into both. So 6 plus -1, does that equal 5? This is my verify. Yes, and then 6 subtract -1, does that equal 7? Yes. Okay, so I know I did it right. Okay, so let's go through the steps here. Some of them may not be necessary as it says. So in this first question, it was set up basically for elimination, because all you had to do is line up the x's, the y's, which it was already lined up for you, and then add it. So not all questions are going to be like that, right? So you may have to multiply one or both equations by a constant so that they have the same number, and they have to be opposite signs. Why do they have to be opposite signs? So they cancel out. So you may have to multiply it by, say a 2 or a -2, so that when you add, I know it says or subtract, but essentially I want you to add it, so just make sure they're opposite signs, so that you can eliminate one of the variables to solve for the other ones. Okay? So next question. Do you see nothing if I were to add right here would cancel? So you need to pick one variable to eliminate and make sure that they have opposite signs. So what do you want to eliminate here? It looks like the easiest one to eliminate would be the x. Why? Because I'd only have to multiply this first equation, say, by -2, right? If I chose to eliminate the y's, I would have to multiply both the first equation and the second equation by a constant to get rid of it. So it doesn't matter, like you can do whatever you want. So we're going to multiply this by -2. Okay, so -2x minus 4y equals -20. And then I'm going to rewrite the second equation exactly the way it is. So 2x plus 3y equals 14. Does everybody see what I did there? I multiplied the first equation by -2. So that now, do you see these will eliminate when I add them? Now, where you'll make mistake is you'll forget to multiply all of them by the constant, right? You have to make sure you multiply each and every term by it. So then, do you see now when I add this, the 2x's will cancel because they're opposite signs and the same multiple. What do you mean, do you have to do that? Okay, I'll show you in a second. So then when I add this, I get -y equals -6. which means y equals 6. And then once I'm done with that, plug it into one of the equations. It doesn't matter which one. So I'm going to do it the first one. So x plus 2 times 6 equals 10. X plus 12 equals 10. So x equals negative 2. So my solution is negative 2, 6. So I'm going to show this again because it's like I blinked, or you blinked and I chose it for you. Does everybody see? If I want it, I'm going to do this. You don't have to copy this down. I'm going to redo this in red. If I want to eliminate the y's, I would have to multiply this one by something that's common that a 2 and a 3 can both go into, which is a 6, and then they have to be opposite signs, which means I multiply the top by 3 and the bottom, say, by negative 2. So watch what happens when I do that. I'm going to multiply the top by 3, so I get 3x plus 6y equals 30. And then the second equation, I'm going to multiply by negative 2, so I get negative 4x minus 6y equals negative 28. Do you see now these would eliminate, right? And I'm left with negative x equals positive 2. So x equals negative 2. And then I'd sub in to get the y's. Do you see? It doesn't matter what you choose to eliminate. It doesn't always have to be x. I only chose x because then I'd only have to multiply the first equation by something. Okay? I'm going to verify my solution then. So here's my verify. Is my x was negative 2, 6. So negative 2 plus 2 times 6, does that equal 10? So that's 12. Negative 2 plus 12, yep. Work there. Remember, you got to check both. So 2 times, again, my x was negative 2, plus 3 times 6 equal 14. So negative 4, does that equal 14? Negative 4 plus 18? Yep. You see it works? So again, that's how you verify that you get 100% on your quizzes and tests, right? By following through with that. Okay, so do you see? What would I have to do? Okay, so this is just a matter of opinion which one you want to eliminate here, because you're going to have to do it to both, right? We're going to eliminate x, okay. Now, just so you know, this one's already opposite signs, so it's almost halfway done, but it doesn't matter. Okay, so somebody said, let's eliminate x. Fine. So how are we going to eliminate x? We got to do what to the first one? Times that one by 3. And what do we have to do to that one? A negative 2. I have to times it by. Does everybody see?
Doesn't matter which one you do. Can you do the top one by negative 3 and the bottom one by 2?
Okay, so if I times the top one by, oh, you're saying for signs? No, it doesn't matter. I thought you meant just random, like, yeah, no. As long as they're opposite signs, doesn't matter which one. Okay, so that means I get 6x plus 9y equals 24. And then the bottom one, if I multiply by negative 2, I get minus 6x plus 10y equals positive 14. Again, it's usually when you do that multiply that you make a mistake if you forget to multiply all of them. So now, do you see we've clearly chosen x to eliminate, and sure enough, when you add them together, they eliminate. And I get 19y equals 38. So y equals 2. Sub it into, doesn't matter which one. So 3x minus 5 times 2 equals negative 7. 3x minus 10 equals minus 7. 3x equals 3. So x equals 1. So my solution then is 1, 2 in brackets, because it's a coordinate, right? Otherwise, you'll lose the error code. And I'm going to verify that it's correct. So 2 times 1 plus 3 times 2, does that equal 8? So this is 2 plus 6, so that works. And then 3 times 1 minus 5 times 2, does that equal minus 7? 3 minus 10, that certainly works. Okay, how about you guys try example 4? Okay, so I'm going to times this by negative 3. So minus 6x plus 9y minus equals minus 42. So I get 16y equals minus 32, so y equals negative 2. Now I'm going to sub that back in, doesn't matter which one. 2x minus 3 times minus 2 equals 14. 2x plus 6 equals 14. 2x equals 8. So x equals 4. So therefore it is 4 comma minus 2. And if I do a quick verification, it would be 6 times 4 plus 7 times minus 2. Does that equal 10? So 24 minus 14. So that one worked. And then 2 times 4 minus 3 times minus 2. Does that equal 14? 8 plus 6, and it does. Okay, try example 5. Try example 5. Okay, so it doesn't matter which one you choose, but this one, if you just multiply it by 2, it eliminates pretty fast. So 4x minus 2y equals 2. 6x plus 2y equals negative 12. Those eliminate. 10x equals negative 10. X equals negative 1. Sub it into the, say, the first one. 4 times negative 1 minus 2y equals 2. Negative 4 minus 2y equals 2. Negative 2y equals 6, so y equals negative 3. Therefore, my negative 1, negative 3 is my solution. Yes? If I do a verify, 4 times negative 1 minus 2 times negative 3, does that equal 2? So that is negative 4 plus 6, and it certainly does. And then if I plug it into 3 times negative 1 plus, I guess it's negative 3, does that equal negative 6? And it does. Okay, so now we're going to go on to some word problems. So same thing, but we're going to try to eliminate it. Okay, so it says create a linear system to model this situation. Make sure you're specific on what the variables stand for here. Ava and Ethan sold flower bulbs for a school fundraiser. Ava sold 5 bags of tulips, 2 bags of daffodils. She raised $80. Ethan sold 1 bag of tulip bulbs and 4 bags of daffodil bulbs, and he raised $70. So, what are the variables here? And don't say T equals tulips. What is it? Is it the number of? No, no. It's the cost of the tulips. The cost of the tulip bulbs. And what are we going to do for daffodil? D? Yeah. And that, again, is the cost of the daffodil. That's why I'm saying you have to be specific. I know how many bags of tulips there are because it says right there. Okay, so Ava sold 5 tulips and 2 bags of daffodils to raise $80. So what's my equation? Very good. T plus 4D equals 70. Very good. Okay, so does everybody see that that would be my 2 equations? Okay, so now we're going to solve it using elimination. Which one's nicely set up to eliminate? The T, right? Because what would I have to multiply this one by? Multiply it by -5. Why -5 and not just 5? They have to be opposite, right? So 5t plus 2d equals 80. This is minus 5t minus 20d equals minus 350. Do you see the 5t's will eliminate? Oh, for sure. You can times the top one by -2 and you could get rid of the d's. Yep. So what do I get here? Negative 18d equals negative 270. So d is yeah. 15. Thank you. And then we're going to sub it into, say, the second one. So I get t plus 4 times 15. That equals 70. 4 times 15 is 60. So t plus 60 equals 70. So t equals $10. Now, what am I supposed to do when it's a word problem? Yes, your answer is not a coordinate pair. It is words. So therefore, the cost of the tulips is $10. And the cost of the daffodils is $15. Okay, I'm going to give you a second to do example 7 now. Okay? Of course, you can verify it too. But do example 7, okay? Okay, so let's read the question here. A store sells running shoes and hiking boots. The store makes $25 profit from the sale of a pair of running shoes and $50 from the sale of a pair of hiking boots. One afternoon, the company sold 14 pairs of footwear for a total profit of $450. How many pairs of running shoes and how many pairs of hiking boots were there? So R equals the number of running shoes, I guess, sold. And then H is the number of hiking boots. I put boots sold. Okay, so from the first bit of information, it says the store makes $25 profit and $50 profit for. So what do I do with the 25 there and the 50? 25R plus 50H. Yeah, and does that make sense to you that if I know I make $25 per running shoe, and if I have the number of running shoes, I multiply that, that should add up to money, right? And then we have to do something with the 14 pairs. So, yeah, R plus H equals 14. Okay. So it's totally up to you which one you want to eliminate here. Which one did you eliminate? Probably going to choose that one and multiply it by, times it by -25. Okay, 25R plus 50H equals 450. Minus 25R minus 25H equals minus, what did we say it was? 350? Those cancel. I'm left with 25H equals 100. So H equals 4. Is that what you got? So then I can just, by pure inspection, if H is 4, then what does R have to be? 10. And then, of course, I have to write it out. Therefore, the company sold 10 pairs of running shoes and 4 pairs of hiking boots.